Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amira Faika binti Muhammad Fadili and my ID number is 2022-814934. I am from class AS1202D and from Diploma Applied Science.
Hi everyone, my name is Amira Yasmin binti Muhammad Noisham from class AS1202D.
My name is Muhammad Amir Rahman bin Osman. I am from class AS1202D.
So, for the introduction, maximum is the largest set in the function. Meanwhile, the minimum is the smallest set in the function. So, what is the use of maximum value? The maximum value of a function is the place where a function reaches its highest point or vertex on a graph. And what is the use of minimum value? The minimum value of the function is the place where the graph has a vertex at its lowest point. So let's move on to the next point. As you can see in the picture, there is local maximum, saddle point, and local minimum. So what is the meaning of local maximum and local minimum? The local maximum is the highest point in the graph. Meanwhile, the local minimum is the lowest point on the graph around the point. So for the saddle point, those critical points where the function attains neither a local maximum value nor a local minimum value. Furthermore, in a smoothly changing function, a maximum or minimum always where the function flattens out, except for the saddle point. So where does it flatten out? Where the slope is 0. And where the slope is 0? The derivative will tell us. So, how do you find the minimum or maximum value of a function? First of all, we need to find the critical point. So, how do we find the critical point? By setting the first derivative equal to 0. Next, we need to plug the value of the critical point into the original function. So, as a result, the value you get will be either a maximum or a minimum value depending on whether the second derivative is positive or negative at the critical point.
For problem statement, if you read this question, an open-top aquarium with a volume of 36 meter cube is to have the length twice as long as its width. Let S and Y be the aquarium's width and height respectively. So, V equal to 36 meter cube and we just don't know the length and weight. So, we just write width is S and 2S for length because in the question, it says length twice as long as its width. Now, we go for a question A. Now, for question A, express Y in terms of S. Formula for volume is V equal to length times weight times height. For the length is 2S times weight S and times height Y. So, the answer is 2S squared Y. But right now, we want to express the Y. 2S to Y equal 36. Bring the 2S squared to other side. Y equal to 36 over 2S squared. Cross 36 and 2. The final answer for this question is Y equal 18 over 2S squared. Question B. Show the surface area of the box is given by A area equal 2S squared plus 100A over S. For this question, we must calculate the area of each face and we have to add the areas together. So, A equal to, in front we have 2SY plus at back we have 2XY plus left side XY plus right side XY and lastly plus top and bottom 2x squared. We got 6xy plus 2x squared. Look at the previous question, question A, we already got y. Sub y into 6xy plus 2x squared. So, 6s times 18 over x squared plus 2x squared. The answer is 108 over x plus 2x squared. Final question is question C. Find the maximum surface area of the box. The question wants the minimum surface area. So first of all, we have to differentiate 2x squared plus 108 over x. Differentiate 2x squared will be for x and for 108 over x will be negative 108 over x squared. After differentiate, we got 4x minus 108 over x squared. And then we have to find the s. 4x minus 108 over x squared equal to 0. 4s equal to 108 over x squared. Bring the x squared to the other side of 4s. Now, 4x has become 4x cubed equal to 108. Bring 4 to the other side multiplied with 108. X cubed equal to 108 over 4. X cubed equal to 27. So, x equal to 3. This is not the final answer yet. S must sub into the area that have been given in question B. So, area equal to 2x squared plus 108 over x. Sub x into the area 2x squared plus 108 over x. So, it becomes 2 times 3 squared plus 108 over 3. 18 plus 36, and we got the final answer 54 meter square.
To sum up our conclusion, the applied maximum and minimum has a lot of function in our life, especially for a person who work in a world of industry like science sector and so on. Applied maximum and minimum also can help us to solve some mathematical questions that might relate with our daily life, such as maximizing area, minimizing cost, maximizing the profit, and others. So it is important to learn and understand about the function of applied maximum and minimum, and also the way to solve this type of question, because it can give us a lot of benefits for our sakes. That's all for me, and thank you.
Lastly, this is our reference that we refer to make our slide presentation. So that's all from us today. Thank you for watching. Hope you guys understand. Assalamualaikum.